some brief information about it. Actually, I will try to focus on a specific application of GRC in structural engineering area as a seismic retrofitting material. We have developed a method actually together with the Fibrobeton company, and they have a collaboration between some Turkish universities. The number of the universities they are collaborating is larger than 20 actually, and they have published more than 100 of scientific papers together with these universities, and more than 30 graduate theses, masters and PhD level theses have been also released by this collaboration. So I will, of course, I will not give all of the details about this collaboration, but I'll try to focus on a specific application that we are collaborating with Fibrobeton company. And also some English universities such as Oxford and Sheffield University. We have two different research groups. We are also collaborating together with Fibrobeton, with some British universities as well. So I will try to give you some brief information about this. First of all, I will give the summary of the collaboration of some technical university, that is the top university, I guess, in terms of structural engineering in Turkey, and İzmir Institute of Technology, my university. And then I will try to give you some needs, retrofitting needs related to the seismic risk in Turkey, given that we have encountered a devastating earthquake on February 6th, and the formal reported number of the casualties exceeding 50,000. So we are living on an earthquake-prone region in Turkey, and we are all aware that. And the worst situation is we are also expecting another earthquake in Istanbul. It is a densely populated city with more than 20 million of people living together in a very tight area. So we are expecting a little bit more devastating consequences with respect to what we have encountered in southeastern of the Turkey. So this is very important, I would like to mention. And in this scope of this collaboration, we also constructed some facilities, and I will try to give you some details about seismic test facility that we have constructed on the area, on the site of the factory site of Fibrobeton company. And we have some preliminary findings of the proposed retrofitting method. Actually, most of them under review of some journals, so mostly they are unpublished works, but I'll try to give you some preliminary findings that we have estimated. Actually, our collaboration together with Fibrobeton company is spanning for more than a decade. This is actually from a previous GRCA Congress that has been published in the preceding book of it. So we have monitored of a GRC panel for around a year under ambient environmental conditions, which is corresponding to -10 plus 40 Celsius degrees. So we have made some measurements on these full-scale panels in Istanbul Technical University campus. And you see here the date of the measurements, which is beginning from 2010 up to 2011. And on the vertical axis, you see the deformations that we have estimated using some strain gauges. Then we have extended the monitoring duration. So we have monitored the deformations of these panels, GRC panels, for more than 4 years. And as a result of it, I will not give you too much detail about the project because these are some published works you can reach easily. This has been presented in the other GRCA Congress in Dubai in the previous one. So you can find much more detail on that proceeding book. So we have monitored the deformations, and we observed that there is no visible damage on the panels after monitoring them for more than 4 years long. Then we have decided to, because after making some optimization works in the material, we have decided to try the applicability of the spraying GRC method in order to enhance the seismic behavior of existing building stock. Because the majority of the building study in Turkey is comprised of substandard buildings, which means that there is no compliance with the current guidelines. Particularly, we have some critical dates, such as 2000, and prior to date, there was no site inspection, or there was no modern seismic code, and ready-mix concrete was not being used no longer, and we didn't have some default bars. We were all using some plain bars, which you all know that we had some home problems with them. So we have tried to use this application, this GRC spray, combined with some basalt mesh reinforcement, in order to provide some lateral load bearing and also ductility capacity to the existing reinforced concrete stock. In Turkey, and also I think in most of the developing countries, we have a huge amount of reinforced concrete. For example, in Turkey, more than 90% of the whole building stock is comprised of reinforced concrete structures. And 80%, around 80% of this building stock has been constructed prior to 2000, meaning that we have serious problems in these buildings. So, one of them is the distance of the stirrups. And the stirrups are resisting to the shear forces, meaning that the seismic forces and reinforced concrete structures. That is why it's very critical, the spacing of the stirrups and reinforced concrete structures. So in this study, that was a pilot study in order to understand if the method is working or not. So after using this for the detailing of substandard columns, for example, with a compressive strength around 10 megapascals, that is the average compressive strength in Turkey, unfortunately. So this is representing the existing building stock. So we have a reinforcement, lateral reinforcement ratio around 2 per thousand or 40 per thousand, and we have applied 3 ply of basalt mesh reinforcement with 2-3 centimeters thick of spray GRC, with 2 different spacing of stirrups configuration. One is 90 centimeters on the left one, on the left figure you see that, the result, and on the right hand you see the one with an 80 centimeters, millimeters of thickness of spacing of stirrups. As you can see, the gap between this one is the reference one, as you can see, and the over it you see the retrofitted one. And here, this is the reference specimen, which means that that's unconfined, unjacketed, and this is the case that we have jacketed this specimen using 3 plies of basalt mesh and then spray GRC. As you can see, this gap, this difference, this vertical difference is corresponding to the contribution of the retrofitting method in terms of lateral load bearing capacity. And this horizontal difference is referring to the ductility enhancement that we have gained using this spray GFRC course. So after estimating this, after conducting this study, this pilot study, we decided to enhance our knowledge in terms of this methodology. So first, we needed to model the behavior of the confined concrete, jacketed concrete. So there was a certain need to make some confined concrete tests. As you can see here, we have tested some under uniaxial compression tests we have conducted on square, rectangular, and circular cross sections. These are again representing some low strength concrete, which is a general property of the existing building stock in Turkey. So on the left hand side, you see in this figure, this is the result of the circular specimens. And here, this one is the reference one with a compressive strength around 9 megapascals or something. And as you can see, the ultimate strain is corresponding to 5 per thousand or something. And this is plain GRC strain. And over it, you see the GRC combined with 1 layer of basalt mesh, and the upper one is the GRC with 3 layers of basalt mesh for circular cross section. And at the middle, you see the results for the square cross section with the same manner. And on the right hand, you see the rectangular ones with a cross sectional aspect ratio of 1.5. So as you can see, of course, as expected, due to the confining pressure provided by the GRC strain, provided by the jacket. So we have a significant enhancement in terms of axial behavior. So it's very critical for us. So we have conducted more than 30 column tests in order to make this published research. We have published in the Journal of Composites for Construction, which is one of the most prestigious journals in structural engineering area, of course. So after that, we understood that we can also model the behavior, so we can pass to the next level. So it is important, so because in order to eliminate the deficiencies in the existing buildings. So as you can see on the screen, 92% of the total buildings in Istanbul, this is the result from the Istanbul study, is comprised of plain reinforcing parts, not the default ones. So their tensile capacity is quite lower with respect to modern default parts. And also there are serious bond problems that we are encountering. So the other deficiency is the spacing of the sphere. We have investigated more than 60,000 buildings in Istanbul. That's an ongoing work together with Istanbul Metropolitan Municipality and Istanbul Technical University, which I'm also included. So the average value of the sphere spacing in the existing buildings is 25 centimeters, and actually the Turkish building code is limiting this spacing with 15 centimeters. So it is half of the required one. Again, the axial load to capacity ratios of the existing columns, as you can see, the mean value is 60%. So it means that the reinforced concrete columns are loaded with 60% of their capacity. It's actually in seismic prone areas, it is again restricted to 40% of them, by Turkish guideline, I mean. And the concrete strength, as you can see, the mean value is around 10 megapascals. And only for the less than 1% of the existing building stock, we observe compressive strength larger than 20 megapascals. So the problem is huge in Turkey. So that is why we are too afraid of the expected great Istanbul earthquake. So we expect a little bit more devastating results, so we have to hurry about it. So these are some pictures that I have taken in the earthquake region, the last one. And after the earthquakes, the government has commissioned some record groups. I was also included one of them. So I visited to make some damage inspection in the earthquake area. So you can see some results from some views from that. So the detailing of the buildings is very problematic, as you can see, in terms of spacing of the spheres, in terms of hook angles, in terms of usage of plain reinforcing parts, poor quality of concrete. That is why we are encountering such kind of soft stir collapses, which is resulting in some devastating results. But the problem is, if you inspect the buildings using the principles of the current guidelines, particularly the Turkish seismic guideline, so it is, of course, giving some methods in order to understand the seismic behavior of the existing buildings. But the problem is, as you can see, the deficiencies are huge. So if you follow the procedure that is described by the Turkish building code, you will see that almost more than 80% of the building stock is not fulfilling the requirement of life safety, that is the performance target for residential buildings. So what can we do for such a huge amount of buildings? If you try to demolish and rebuild all of these buildings, it will cost more than 500 billion euros. Right? So it's not possible, only for Istanbul. So we have many cities under the earthquake risk. So it's not possible to simply demolish and rebuild all of these buildings. We don't have money, we don't have budget, we don't have time also. So we are expecting Istanbul. So we are trying to make some prioritizing studies, for example, to separate the buildings depending upon the estimated risk. So we are doing some rapid seismic assessment methodologies that we have proposed that, and the Istanbul municipality is using it. So we are trying to classify the buildings with high risk, very high risk, medium risk, and low risk. As you can see here, the fail and pass buildings. So we have to separate failed buildings with subgroups. So after that, they are trying to estimate an intervention prioritization. For example, if the capacity over demand ratio is between 0 and 25, we immediately make some intervention. We have to do it. Either retrofit or demolition. If it is between 25 and 50, we are making some intervention. We are planning to do some intervention between 1 and 3 years. So it is depending upon the demand over capacity ratio that we are estimating using the study. So with this purpose, we have constructed a new facility to represent the deficiencies of the existing blocks in Turkey. For example, this was an existing mock-up building, and the Fibrobeton company is handling some facade elements here. They are making some full-scale tests. They were making prior to us, and also they were making some demonstrations to the clients. So we have used that building as a reference for us. We added some shear walls in order to create a strong reaction wall to make such kind of seismic tests. Then we have to we have to create a strong floor in order to apply some axial loads on the floor level, as you can see. And that is the final case. We have constructed some full-scale columns, reinforced concrete columns, representing the existing building stock. Using this kind of horizontal actuator, we have estimated this is capable of applying around 60 tons of horizontal load. And we have some jacks which is capable of applying 200 tons. That was the capacity of some columns with high aspect ratio, so we have to use it. So after that, we have conducted some research with many parameters included representing the existing building stock. As you can see, first we have rounded the corners in order to enhance the lateral pressure and the uniformity of it. Then using some spray guns, we have sprayed the GRC material over the columns. These are some substandard columns. For example, for this study, the parameter was the cross-sectional aspect ratio. So if you increase the cross-sectional aspect ratio, we have very limited options to retrofit the existing building columns. For example, we can use some fiber-reinforced polymer composites in terms of sheets. We can apply it, but we cannot do it if the cross-sectional aspect ratio is exceeding 2 in Turkey. It's forbidden. So if you have problem related to ductility, we don't have any too much option. The jacketing of concrete jacketing, reinforced concrete jacketing or steel jacketing are not quite reliable solutions in Turkey. There are some limitations. We don't have so much time on the discussion of these things, but in order to enhance the stiffness as well as ductility and lateral load bearing capacity, we need such kind of a jacketing method. And we have checked it, and as you can see on the screen, for aspect ratio 2 and aspect ratio 4, aspect ratio 2 means that the dimensions are 20 centimeters by 4 centimeters, and here for 4, that is 20 centimeters by 80 centimeters. So as you can see, in terms of ductility, we have enhanced a significant behavior in terms of seismic behavior. So another problem is the behavior under high shear demands and under high axial load ratios, which are among the other deficiencies in Turkey. As you can see, the continuous bar is continuous line is representing the reference one, and the other two options are the GRC with volumetric ratio of 5% and 3.5% with a combination of puzzle mesh reinforcement. So as you can see, in both things, we are increasing the stiffness and the lateral load bearing capacity and the ductility, which can be simply defined as the ability of deformation without a considerable loss in the lateral load bearing capacity. That is the ductility, which is the main concept in Turkish earthquake coding structural design. So there is also another ongoing work. Hopefully we will do it in 2 months. It will be completed. We have made a good enhancement in the project. So in this case, we have a setup, as you can see on the right hand. So we are applying 80% of the capacity as an axial load. So and then we are waiting for some period of time. For example, for 6 months, 12 months, 18 months, and 2 years, which is considering the existing buildings, because the existing buildings under the service loads, they are under some axial loads in their service lives. So in order to represent the impact of the sustained load during the service of the building, we are conducting such a test, and after we have completed the 24 months, so in 2 months, we will conduct the rest of the study, and we will terminate all of the ongoing works. And as a conclusion, as a consequence of the industry and university collaboration, which was initiated from long-term monitoring of the panels, and it has finally resulted in the development of an innovative retrofitting method using straight GRC with various forms, various contribution of other materials, in some hybrid forms particularly, of course. So I have tried to give you some basic principles of the collaboration. Actually, as I mentioned, it is a comprehensive work, and it will be published soon. I think up to the end of this year we will publish all of the papers. Considering the promptness and the ease of implementation, straight GRC may be a feasible alternative to the conventional retrofitting methods. And also, as I mentioned, in some circumstances, we don't have so much options while retrofitting our building stock in Turkey. And the efficiency of the method in terms of improving the lateral strength, ductility, and stiffness was clearly proven in the study under extreme conditions. We see that it's working. After completion of the ongoing works, all compiled data in scope of the collaboration will also, we hope that enable the development of design methods and provisions of the method. So we are working on that issue. I hope that Turkey will be the first country which is releasing a code, a formal code of the government, which is including the seismic usage of straight GRC in seismic applications. We will try to form a code. A large amount of professors working on that issue. In Turkish building earthquake, we have some chapter on the usage of fiber reinforced polymers in seismic applications. So after modeling all of these works and after publishing at the end of this year, hopefully next year we will publish a guideline, seismic guideline. Thank you very much for listening.